In this section, what we want to do is we want to start to be using what we know about matrices in order to solve a systems of equations and bind those two concepts together and see their relevance. And so what we're going to do is we're going to explore this idea of something called an augmented matrix in reduced row echelon form. And so what we're doing is when we're creating an augmented matrix, we are taking what we know from a system, putting it into a matrix in an organized fashion, and then what we'll do is different operations in order to create a matrix that results in answers. And so first, let's start with what is an augmented matrix. Here we have an example so we can kind of see where things are coming from. And so in order for us to create an augmented matrix to reflect what this system is, here's what we're going to do. So first, I'm going to set up my matrix. We are going to have as many rows as we have equations and as many columns as we have variables combined with constants. So in this case, I have two variables and a constant, so I'm going to have 3 columns, and I'm going to have 2 rows because I only have 2 equations in the system. And so when you create this, you do want to make sure you have everything in standard form of all your variables on the left side and your constants on the right. And so I will say, okay, I'm going to make a row of all of my x values, or a column, of all of my x values. So I'll have -3 and +5. Now, when we input into a matrices, it is all numerical values. When we're doing this augmented form, we are not going to put in any x's or y's. But I'm making the x underneath here because I'm going to show you where those numbers are coming from. Then I'm going to make a column of my y values. So that gives me -2 and -5. You can see column-wise, those are y values here. But row-wise, it's relating to the row of that equation. So I'm not jumbling them all up. Then an augmented matrix, what it does is it kind of does a horizontal line when we're writing it out, not necessarily if we use a matrix technology, to represent the equal sign. And then what you would do is write your constants. And so I would have 9 from the top one and -40 from the bottom one. This is your augmented matrix, where I have inputted all the coefficients and constant values in an organized manner where variables are lined up vertically and equations are lined up horizontally. Now, how can this help me? What I'll be able to do is move into our next vocabulary word here is a reduced row echelon form. And so what does it mean to get a matrix in reduced row echelon form? It's in order to make diagonals of 1s and everything else 0s. And so in essence, we're manipulating the matrix to reveal what singular variables are equal to. So I want to walk through that process, and then we'll approach this differently in the next example. And so I'm going to go ahead and erase this x, y, and z. That was just showing us how we were getting that. So in the process of creating this reduced row echelon form, again, end game is to figure out what x and y equal for the system, is step 1, you're going to create that augmented matrix. And step number 2, we're going to create a 1 somewhere along our diagonal. And so what I want to do is I want to manipulate my matrix, my rows of matrix, in order to get this down to a 1 somewhere in here. And so the first thing that I'm going to do is I'm going to take the row 2 and I'm going to divide everything by 5 or multiply by a 1/5. And once I do that operation in row 2, I'm going to replace it as row 1. And so I'll say row 2. So I'm taking this row here, and I'm going to divide everything by 5 or multiply through by 1/5. And so that is going to give me 1, -5, -40 times the 1/5 gives me a -8. Now I am going to replace it as row 1, and I'm going to bump row 1 down into the bottom part. So this -3, -2, and 9 is going to drop down. So I still have both equations from the system, but I've divided everything in that second row by 5 and then moved it up to the top and interchanged those rows. And so what my goal in doing that was that I could create a 1 right here. When you're looking at row echelon form, our goal is to create diagonals of 1 values. So now that I have this 1 right here, I'm going to work to create another 1 along the diagonal or zeros other places. And so in this problem for step 3, I'm going to take my matrix. I'm still going to have 2 rows, but I'm going to manipulate this a little bit. I'm going to leave the top, excuse me, you're probably thinking, where did I get this -5 right here? I forgot to divide that one. And so I'm going to take that top row, I'm going to leave it alone. I like where that has that +1, and I'm going to take and create a 0, or my goal is to create a 0 right here. In order to create that 0 right there, you kind of use your systems of equations. I'm going to take my row 1 and multiply it by 3. I'm going to add it to my row 2 so that I can possibly create that 0. That's my goal. And then put that input as a new row 2. Now, if I lose you along this way, just hang tight with me. There's a pattern, there's a process, there's a purpose. And so what I'm going to do is I'm going to take row 1 and multiply it by 3 and then add it back in. So when I multiply that by 3, that gives me 3 in the top, -3, and then -24. I'm going to add that to that row that I already have, and once I add that, I'm going to put that in as my result. So 3 and -3 gives me a 0. I'm going to add these two together, that gives me -5. I'm going to add these two together, and that gives me a -15. And so through this process, I'm going to rate this little scratch work here. I was able to take row 1, multiply it by 3, add it to row 2, and you can see almost through an elimination like we did with systems, I was able to create a 0 right there. So I'm creating diagonals. Again, my goal, create diagonals on the 1 of 1s and everything else be 0. Now I'm going to do this again. So this is looking really good. I'm liking where this is going. I want to keep kind of working through these row operations. And so in the next one, what I want to do is I want to create a 1 right here. And because I have 0 here, I could probably just do some row operations to figure that one out. And so I'm going to take my matrix. I'm good with that top row. We'll deal with that in a minute. And I am going to divide everything by a -5 this time, or multiply through by a -1/5 on row 2 and replace it with row 2. And so 0 divided by -5 is 0. -5 divided by -5 gives me a 1. And I'm just manipulating these values by this much. And then -15 divided by -5 gives me a +3. And so now I like this one, I like this 0, and I like this one. So the last thing I want to do is create a 0 right here. And that'll give me 1s on the diagonal, everything else to be 0. So step number 5, looking at this matrix. The bottom row is looking really nice. But what I want to do is create, again, we talked about create a 0 right here. So I am going to take row 1, add it to row 2, and replace that in row 2. So I'm just adding this row into this top row and putting the result in my new matrix. And so 0, 0, and 1, when I add them together, that gives me 1. And then 1 and -1, add it together, gives me 0. That's my intention. And then add these two together and put the result here. So that would give me -5. And so again, you can see, make diagonal of 1s, everything else 0. I've got my diagonal of 1s, everything else is 0. So what this tells me is, remember earlier we said these were our x's and these were our y's, these were a constant. So this is telling me that my x is equal to -5, so x, -5. And my y is equal to, y in that column is equal to 3. And so what these reduced row echelon form situations are going to do for us is allow us to manipulate just coefficients. We didn't have to deal with any of our variables until we get to that reduced row echelon form, and then that's going to output our answers. Now, through this whole process, you were probably like, you lost me. I have no clue what you just did. Well, I wanted to show you in one example on how all these pieces come out. And then what I want to do is I want to take our 3 variable example, like we saw earlier in our solving of systems, and show you how doing this row echelon form is going to work out for us. So the first thing we're going to do is create our augmented matrix. So I'm going to take out the hard part of all these letters in here. Again, we're going to line them up. So what I'm going to do is I'm going to put my X's, my Y's, my Z's, and then my constants to create this matrix. So in my X's, I'm just taking coefficients. That would be 15, 12, -6. And then I just want to put my Y's in here, just the coefficients. So -10, -11, and 4. And then do my Z's, which is 1, 2, -1. And then those constant terms, -38, -40, and 17. Once you've created your augmented matrix, don't freak out. We do want to do a reduced row echelon form, but we're going to use a matrix calculator to help us with that. So let's see what that looks like on our matrix calculator. So here's our matrix calculator. We've already looked at this with some operations of sort, and so we're going to create a new matrix. We did have 3 rows by 4 columns. I'm going to input what we just wrote down: 15, -10. Let's see. Oh, excuse me. 12, -6. And I'm just inputting everything we just wrote down. -11, 4, 1, 2, -1. Just putting them all in just like I wrote on my paper. It does help to kind of go ahead and jot down what you're wanting to entering and not try to look back at your system while you're going to this calculator. And so I've got my whole augmented matrix in there. I'm going to hit enter, so it's going to save that. So that's my matrix A. So then from matrix A, what I'm going to do is I am going to do reduced row echelon form that's shortened to reduced row echelon form. So I'll do reduced row echelon form, and then I'm going to name what matrix I want it to do it to, and we have a matrix A. And then you can see that it outputted the answers. And these are the exact same answers from when we talked about how to do systems of equations with 3 variables. And so you can see those answers still came about, but a whole lot less work. Now, if you really hated what we did in the first example and doing all the reduced row echelon form of dividing by 5 and then taking 3 times a row and adding it all together, let me show you that example. So I'm going to do a new matrix. The first example that we started with had 2 rows by 3 columns. I'm going to input the augmented one that I created. Again, it's just all the coefficients on your variables. Let's see. So that gives us these. Again, just like what we had in the previous example. And we did all those steps, and I may have lost some of you on that. But this also shows us that we can appreciate this button. So if we do RREF of our matrix B, you can see that our output is still -5. So we do have to be able to read the results. X to be -5, and then Y to be 3. And so let's jump back over into our notes and jot down what we just did. And so here we are in our notes. We can see that step 1, we are going to do an augmented matrix. Step number 2, you're going to enter the matrix onto the matrix calculator. Step 3, you're going to do RREF of your entered matrix and hit enter. And then we saw what that result was. It gave me out 100. Just pulling this from my calculator over there. So you can see that we have those ones on that diagonal that we were talking about and zeros everywhere else. And then the answers were -1 to -3, which we've already done all the hard work of solving that system. So in this video, I just wanted to show you how we can do an augmented matrix and use the matrix calculator in order to solve systems. So this makes this a really good guide on how to output all this together. Again, go and try the homework and then reach out for assistance if you need it.